this part, we are going to learn about math functions in C++. Math functions help us perform advanced mathematical operations like square roots, powers, rounding numbers, absolute values, and more. And these functions are provided by the C math library. So before using any math function, we must include it. Okay, so let us now take a look at how we can include the C math library. So to use the math functions in C++, we include the C math header file. Okay, and we include it like this. So above our using namespace std line, we are going to use our preprocessor directive hashtag include. Want to include the C math header file like that. Okay, so from there we can now get access to the math functions. Okay, so the C math library contains all the built-in math functions we will be using. Okay, so let us first take a look at the first one, which is the square root, which is the square root function. Okay, so this square root function, we use it by typing sqrt like that. Sqrt, that's our square root function, and this square root function takes in a float. Okay, so the square root function is used to find the square root of a number. Okay, so and if we try to provide, let us provide 4.0, or instead of 4.0, let us provide, we can provide 4.0, we can provide, let us provide 8.0, and let us add a semicolon, and we want to output, okay, the return value. As you can see here, if we try to hover over our square root, it's going to return a double. Okay, so we are going to output that double in the console using the console out. And if we try to save and we go in our terminal, we try to compile. Let us try to compile. I'm using here, let me change to PowerShell. Okay, so from there, let me try to use /. Then I'm going, we need to compile. Okay, we need to compile, and we are going to compile using G++. After compiling, we are going to run our program. Okay, so we are going to run it like that. /main, as you can see. So the square root of 8.0 is 2.82843, and if we change, let us change to 64. Okay, let us change to 64, because we know the square root of 64 is 8. So if we try to compile and we run, as you can see, we get 8. So square root 64 calculates the square, the sqrt 64 calculates the square root of 64. The output here we get 8. So the sqrt function always returns a double value. Okay, so let us take a look at another one, which is the power. Okay, so the power function, we use it like this. We use poll. Okay, poll like that, and then a parenthesis, and this one takes in two. Okay, it takes in two parameters or arguments, and it returns a float. Okay, so these ones that we should provide, they are float. Okay, they are float values. They are two float parameter values. Okay, as you can see. So the poll function raises a number to a given power. Okay, so if we provide 2 and 3, we are going to this is going to be the power, so we are going to have 2 power 3 like that. Okay, so this means that 2 is raised to the power of 3, which means we get 2 times 2 times 2. Okay, 3 times, and the output here, we are going to get something like I think we are going to get 8. So if I try to output the return, the value that's going to be returned by power, I try to compile. After compiling, we can try to run. As you can see, we get we get 8 and 8. Okay, so here on the first line we return 8, we get 8, and then on the second line, when we use square root, we get 8. Okay, so that's why we are getting 2 8s, not 88. Okay, so let us now take a look at the absolute value. So the abs function returns the positive version of a number. Okay, so for instance, if we have we can use our function just like this. So we use abs, and then inside our function, let us provide a number, like let us provide the negative 25. Okay, so if we try to save and we go in our terminal, we try to compile. After compiling, we try to run. As you can see, we get 25 without the negative. So what if we provide 25 without the negative? We Let us take a look at what we are going to get. So we are going to get 25 as well. So the abs function, or the absolute value function, returns the positive version of a number. Okay, so even though negative 25 is negative, abs removes the minus sign, and the output we get 25. Okay, so let us take a look at another function, which is the round function, and this one rounds of numbers. Okay, so the round function rounds to the nearest whole number. Okay, so we use it like this. So we call round like that, round, and then inside we can round. Let us round 4.6. Let's round 4.6 like that. We try to save and we try to compile. After compiling, we try to run. As you can see, we get 5. Okay, we get 5. Okay, so let us now take a look at another one which is used in rounding numbers. We have the first one, which is called the floor. Okay, or the second one is called the floor. Okay, so the floor rounds down to the nearest whole number. Okay, so for example, if we have 4.6, we are going to round down. Okay, so instead of getting 5, if we try to use the floor like that, we try to compile. After compiling, we try to run. As you can see, we get 4. Okay, instead of 5. Okay, and we have another one which is called the cell. Okay, so cell rounds up, okay, to the nearest whole number. So if we change this one to cell, we try to save. After saving, we try to compile. As you can see, we are going to get 5. As you can see, even if we have 4.1, we try to save and we try to compile. After compiling, let us try to run. As you can see, we get 5. Okay, even if we have 4.1. Okay, so let us take a look at how we can get the minimum and the maximum number. Okay, between two numbers. Okay, between two numbers. So for that, we use the mean and the max functions. Okay, so let us delete all these ones, and these ones, they take two parameters. Okay, so if we have mean like that, and as you can see here, this one can take multiple values. Okay, so as you can see, we have constant tp, and this one underscore a, and we have constant. So we shall take a look at these ones later, but this does what you think it does. So this underscore a thing of arbitrary type. Okay, so we shall take a look at these ones later. Okay, so let us provide two values. Let us provide 5 and 10. So what's the minimum there? So the minimum is 5. Yeah, mathematically that's it. Let us try to see. As you can see, we get 5. Okay, so can we provide another parameter or argument? Let us provide, instead of 10, let us provide 20. Let us provide 90. Let us provide 40. Okay, so like that. Okay, like that. So as you can see, we exceeding the limit. So no instance of overloaded function matches the argument list. Okay, so here we have 2 plus overload. So let us provide only only 4 numbers. As you can see, we still get that error. Let us provide 3 numbers. As you can see, the error has gone. So if I try to save, and let me add, instead of 40, let me add 4. I try to save and then try to compile. Let us take a look at what we are going to get. So as you can see here, we're getting an error. As you can see here, required from here. Okay, so here node cannot be used as a function. Okay, so here we are getting an error. Okay, so we should provide 2 arguments. Okay, like that, 2 arguments, or you can call them parameters. Like that, we try to save and we go down in our terminal. We try to compile. After compiling, we try to run. As you can see, we get 4. Okay, so let us get the maximum. So for the maximum, we use max, the max function, and then we provide our two values. Okay, we can now try to compile. After compiling, we try to run. As you can see, so the maximum here is 10. Okay, and the minimum that we got is 4. Okay, so min returns the smallest number, and max returns the bigger number. The min returns the smaller number, and the max returns the bigger number. Okay, so let us now take a look at trigonometric functions. So C++ also provides trigonometric functions like sine, cosine, and tangent. Okay, so to use them, we can just use them the normal way. So let us get the sine of 0. So I will just change from max to sine of 0. If I try to compile, after compiling, let us try to run. As you can see, sine of 0 is 0. So trigonometric functions use radians, not degrees. So sine 0 returns a 0. Okay, so you should note that. Okay, so in summary, we learned how to use math functions like square root, sqrt, power, POW, and absolute, which is ABS, and rounding functions, minimum and maximum, and trigonometric functions in C++. So always remember to include the CMath library when working with math functions. And if you found this part helpful, like, subscribe, and see you in the next C++ part. Okay, so we can now without leaving, let me show you. We can also use cos. Can we use cos like that? Okay, it's possible. Okay, yeah, that's it. Thank you.